I'm going to start with Chapter 7, One-Dimensional Arrays. Okay. All right. Just to talk about what one-dimensional arrays are, they're basically just if you think about like a block of variables that are all together where you can access them very easily. So if I needed to use, like, let's say as an example, I had 10 variables, and they're all integers. You could write like a integer variable x1, x2, x3, x4, all the way up to x10. And you could do that for any variable type if you wanted to, or any data type that you wanted to. But the problem is that it gets to be if you needed 100 or 1,000 variables or even more, um, it gets to be just really unwieldy and not really a reasonable thing that you could do it that way. So C++ and other languages have this idea of an array. So it's basically like a block of variables that are all accessed in an easy way where you just use what's called an index to access each of them. Okay? So it's much simpler. All right. Now, what we're going to see is that arrays are going to be very useful for a few things, at least a few things that we're going to talk about. And one is sorting. So if you had information and you wanted to sort it, you can think about something like a phone book, right? Phone book things would be in alphabetical order. But when you originally start adding entries, you have to, go through a process either inserting it into the right place or you have to go through and resort your list each time you have a new entry. Okay? So we're going to use arrays for that. So you can figure out, and what we're going to do is we're going to look at some sorting algorithms. And actually, we're going to look at just one. Actually, selection sort is the algorithm we're going to look at. But there are other ones out there. And the basic idea is you're just going to sort things alphabetically or numerically or either ascending or descending order. Um, that's basically what we're going to do with that. And then we're going to look at searching algorithms. Now, sometimes when you're searching for items, they might not be sorted. It might not be sorted. If you can imagine, if you're looking through a phone book and the names were not sorted in alphabetical order, how long it would take you to find a name. So we have both searching algorithms where their information is not sorted, and we're also going to look at searching algorithms where the information is sorted. So one of the things that can happen typically for if you have a list that's of items that are sorted, what you would do is you would sort them first, and then you would use a searching algorithm. And what you recognize right off the bat that if items are sorted, typically your searching algorithm can find them a lot quicker. Okay. The next thing we're going to look at is the so-called character strings, and then the string class. And so far, when we've looked at variables, we've had our basic types, and one of them is character. One of our variable types was character. But character is limited in that it can only have one character. So if you think about or char data type, if you think about having like a name or an address or something like that, a word or a phrase, that it really doesn't work out too well. Although you can work with character strings with the character type, and you could actually have a character type of an array. Um, there's an easier way typically, and that's with something called a string class. Okay, so the way to think about it is you have character strings and you have string class. These are both to work with sequences of characters or words or phrases. Okay, okay, all right. So we're looking at some of the things, just initialization, computation, and using arrays in functions, right? Function calls. So we're going to look at that too. Okay, first thing, what it is. Basic idea, it's just a structure for storing contiguous block of data. Like I said, it could be integer type, it could be float type, double type, character type. It could even be string type if a little bit further along. We're not going to do that, use that type for an array, but it could be. And how do you access the individual variables, or what they call the individual elements? And we're going to use what's called an offset. Okay. And one of the things to pay attention to, it always starts at 0. Okay. So here's the basic syntax of it. And what I'll do is I'll go create a program, but I'll write a program and we'll work with these a little bit just to show you how this works. Um, so the first thing is you have a data type. Like here's an example. So doubles the data type. And then you have the identifier. So whatever you want to call this is your identifier or variable name, you can think about it, or array name. This is the array name, and this is the size. So what this does, if you have this in your code, here is the declaration, double data type. So it's going to be a double data type array, because it has these square brackets. It's going to be called M, and its size is 8. Okay. So what I'll do now is I'll start Visual Studio and we'll start to code this up. So then we can kind of cycle back and forth between it and test the programs out as we go along. Okay, so I'm going to start Visual Studio. And we're going to make this create a new project. And it's console app, of course. Check that. Next. And name will be arrays. I'll do chapter 7 arrays. Arrays example. Huh. Mm-hmm. It's in Chinese. What do you know? Let's put it in English. Arrays example 1. Okay. Create. And as usual, I put it up on the desktop. So just get rid of all this stuff. Don't care about this. And then we're going to go. All right. So we'll do using namespace std. Okay. And then we'll do a return down here. Return 0. System pause. And that'd be good. Okay. So let's start with this. We're going to do, I'll just do double M and 8. Okay. So that just creates an array of double data type of size 8. So it has 8 elements. And 8, declare an 8 element array of double data type. Okay. The next thing you could do, if you wanted to access an individual element. So let's say I wanted to access the first element of this. And I want to set that to a 1. This says set first element in the array to 1. Okay. Then I could do the second element. That's the second element. Let's say that's 6. And it's the same thing. Set second element in array to 6. And I could keep doing this. I could go all the way up to, I could keep going all the way up to element the 7 index, or the 8th element, where use 7 is the offset. Okay. Then I could do this, see out, and I'll do element 1, or I'll just do this, do 0. Then I'll do a tab. That's a tab. I'm going to do an element 1 and line. So that's how you would display them, right? So this is like you're setting each element to a value. And this one here is just going to put it right out to the display, okay? So let me run this. And there you go. There's elements. The first element, which is offset 0, and then the second element, which is offset 1. Okay? Okay. Let's go back to the slides. Okay, continuing on. All right, now to initialize an array, you can actually, like I set the values of the array, but you can actually, in your declaration statement, you could also initialize it. Okay, and here's some examples of it. You can initialize it like this. The only thing I'll tell you is that when you do double quotes like this, what it's going to do is going to assign the first one to the letter, the next letter, the next letter, the next letter. And then when you do double quotes, it's actually defining it as a string. So in the end, what it does is it puts this null character, which is actually just \0, which is actually a 0. It puts a 0 value in that into memory. Okay. So this is how it identifies it as a string. This is a little bit different than what was done here, where you identify each one as an individual character and write them out. Then there's no null at the end. Only when you do the double quotes, you'll see that null. And that gets to be important when we start to use certain functions with strings. Okay, that it knows when you get to the end. Now, another thing you'll notice here is that in this case, they specified the size. So size matched how many different elements you put in. But here, the Boolean, ANSKey being the name of it, did not specify a size. And what actually happens here is that it will make it of size as needed by how many elements you've assigned or you've initialized. 1, 2, 3, 4, 5, 6. So this one is going to be of size 6. And this one, of course, 1, 2, 3, 4, 5, one more, 6. This is going to be size 6 also because you defined it as a string. Okay? So you don't have to specify the size when you first declare it as long as you're initializing it. Okay? If you don't initialize it, then you have to declare the size. One thing also to pay attention here, you cannot put a variable in here. This has to be a constant. Okay? So this is allocated before at the time when the program is actually loaded into memory and starts execution. So you cannot put a variable in here. It has to be a constant. Okay? All right. Let's just take a quick look and just going back to our example. So let's say I didn't want to do it like that. I just said equals. And I want to do a 1, comma, 6. Oh, I didn't spell declare right, did I? Okay. And then the rest will actually be initialized to 0. So you can leave this after that. So I could say just the first two elements. And if I left this off like this, it would make an array of size 2. I'm sorry, of size 2. If I left it in, it would be a size 8. Okay, so two different ways. So if I leave it like that, and then I just comment these out, what you'll see what happens here. And I run it, it's essentially going to do the same thing. And there it is, the 1 and 6. Okay, so you can also initialize it. All right, so that shows you doing that. Okay, continuing on here. And this is like what I showed you. If you wanted to access the elements, here's where you're actually setting them to values, okay? You can also use integer expressions. In other words, if you have something in here between the square brackets, it's an expression, it evaluates out to a number, an integer. You can also put that in here too. All right, so it saves you. You might want to perform some operation or some calculation, and then the result of that calculation you use that number to actually access an element. So you can actually put a calculation in here, or an expression if you want to call it that. Okay. Next thing we'll look at is functions and arrays. Okay. How do we pass arrays to functions? Okay. Now, one of the things to pay attention to here is that arrays are passed by reference, right? It passes the address. Okay. So this is like we previously looked at. We looked at pass by value and pass by reference. Arrays actually don't get passed by value. They get passed by reference. So the address of the first element is what gets passed in to your function when you use them. Okay. All right. Now, one more thing we need to pay attention to is if you pass in the address of the array by itself, it doesn't really contain the information of how big the array is. So you'll also need to pass in the size of the array. Okay, so that'll be part of what we do. All right. So with that in mind, you need to specify an additional parameter. All right. So you need to pass in the size of the array. Okay. So here's a function, and this is a function to find the minimum value of an array. Okay. But before we take a look at that one, we'll go back to our program, and we'll just show you how it works, and then we'll take a look at this function. Okay, going back to our program, what we're going to do is I'll create an array. I'm just going to call this one a void. I'm going to create a function, and I'm going to pass my array into it. So I'll just call it fun function, and I'm going to pass an array in. So I'm going to define it as this. I have a double type array, so I'm going to say double, and I'm going to do square brackets like that. And then I'm also going to pass in a number, and I'll say that's an integer. Okay. So here's my function prototype for passing an array. So function and prototype for passing an array. Okay. All right. And then we're going to go down to our, at the bottom here, and I'm going to do the same thing again. Void function. I'm going to say double. And I'm just going to call my array A inside of here, okay? Just like this, comma. And I'm going to say integer size, okay? So I'm going to pass that in also. And for now, our arrays have actually just size 2, okay? Inside of here, what I'm going to do is I'm going to do whatever, set some of the values here, but let me set, I'll tell you what, I'm going to go up here and I'm going to change this to 8, okay? So I'm going to leave that. That way I can do some more variables in here. I'm going to say A equals, A, we'll do element 2 equals minus 99, okay? Then inside here, I'm just going to go cout A 2 and line, okay? Okay, so all it does is we're going to call this function. We're going to pass this array in. I'm going to do that right here. So I'm going to call my function and say function fun, and I'm going to pass in m, and then I'm going to pass in the size, which is 8. Okay. All right. And then I'm going to run it. So you can see what happens. So what happens here is that, you know, we print out 1 and 6 just like before. And then I call my function, I pass in the array, which is m, and I pass in the size, which is 8, which I don't use just yet, but we'll do that shortly. And then what happens is A and M essentially point to the same place in memory. So there's essentially the same array. The only thing is that when you're the function, it doesn't know anything about M. It only knows about A, because that's what was declared in the function header. So you use A to access M, essentially, okay? And all we're doing is we're going to just print it here. We're going to write it, not print it, sorry. We're going to set it to minus 99, and then we're going to write it out to the display, okay? So we should expect, you know, what happens. 1 gets printed, displayed. 6 gets displayed here. And then the function gets called. And then we set the next element, which is the third element in the array, equal to a minus 99, and then we display it, okay? So we run it, and there it is. There's my minus 99, okay? Now, this was passed by reference. So this A and the M both were pointing to the same place and location, same location. So if I do this, this will also print minus 99. Oh. So we run it. And there it is, minus 99, minus 99. Okay. Now, the sizes, it could be useful for us here. And I'll change this just slightly just to show you. So, like if you wanted to do some operations in this function and you only wanted to go through the whole array, then of course you would do that. So what I can do here, I'm just going to, for integer I equal to 0, I less than the size. Remember, size is 8. We only want to go up to 7. We want to go to 0 to 7. And then I plus plus. And then what I can do is just A I, that's the elements, equals, I'll just say I times I. Okay? So now what I'm going to do is I'm going to go through and display, I mean not display, but set I, each element I just equal to I times I. So now when this runs, can you predict what's going to happen? Well, this line doesn't do anything, so I'm just going to get rid of it here, comment it out. And so it's going to go through and set all these values. It's going to run. And then what happens? After the function finishes, it comes back out and then starts executing from here. It's going to display this. So what will this element do? What will this contain? What will this display? Can you predict it before you run it? Okay? And I'll run it and show you and see if it makes sense. And there it is, 4. And the reason it's 4, of course, is because it did 0 times 0 for the first element. Then it did 1 times 1, which was the second element. And this is the third element in the array. And then it does 2 times 2, which is 4. Okay? So that's basic operation for that. All right. Okay. Now going back to this example, what this example is doing, and this is going to be a very useful code for us as we progress and we start to look at like sorting and searching algorithms. This one is a program that will go and find the minimum value in an array. Okay. So what I'm going to do, I'm just going to take this and I'm going to copy it over. Just going to copy it and use it. That way we can save the time from coding. And I'll tell you what, I'm going to go create file, new project, and console app. Next. I'm going to call this one chapter 7 min. Is it min value? I think it's min value, not max value. It is minimum, yes. I'll say find min. Create. Okay. So I'm just going to copy this over. So there's my code for that. And then I got to go to the next slide and get the actual function. Let's copy this over. Okay. And here's the function. Okay. All right. So what we can do is I'll talk about this first. So let me go here. Okay. So what's actually happening here is 200, is that too big? All right, there we go. Okay. So what we have is we populate an array with some numbers, and they're floating point numbers, double type. And we have a value count, and then we have a position, okay? Count just being like the size of this array. So here's my count, which is just the number of elements. I used a variable count in this example. Then when it actually makes a function call, it uses size, okay? And then what it does is it makes a function call, and the find minimum function goes through and finds the actual minimum value. And then after it gets back, it says its smallest value in the array is this value. What it actually does is it's going to send back the location of that minimum value. See, the expectation is position. This is position 0, 1, 2. This will send back, if this is working properly, it will send back position 2. And then it uses it, DARR is the array, and it says position 2, puts that in, and it'll display the 3.2. Okay? So then we'll go run it, and then I'll talk about the function a little bit more. Oh, I didn't do my system pause, so let me do a system pause here. Okay, let me run it again. Okay, so there's the 3.2. Okay. So how this works is it starts off with offset minimum. Okay. Now offset minimum essentially tells you where is the minimum value located. Okay. And that will keep track of it. So the first thing we say is, well, we're looking at the first element. Let's make that one the smallest one. Okay. Because it's the only one in the array so far. So we're only looking at one so far, right? When we look, because what we're going to do is we're going to make a comparison each time. We're going to look at the smallest element, and we're going to compare it, the smallest one, to every number sequentially, one after another. Okay. So first thing to do is we say position of the smallest number one is, to start with, is position 0. Okay. So we use that. So here it is. It would say position 0 to start, and then it would say compare it to the first one. So it says 10.1, which is this. Compare it to the next element, which is 5.6. So it looks at the two, makes a comparison, and then says, is 5.6 less than 10? Yes. So if that's true, it sets the new offset equal to the new position, the position that we just looked at, which is this one. Okay? So after this loops one time, it has a new position of 1. So that's really just, we've only looked at these two values so far, right? Our array up to this point is only up to 5.6. Then it loops back up, and it sets I equal to 2. Now it's going to be looking at comparing the offset position, which is which points to 5.6, and the new one, which is 2. A to 2, which is now my 3.2. Okay? So now it looks at it again, says, yes, that's true. And it sets 2 as the offset minimum of minimum. So now the offset minimum, now it's really pointing to this one. Okay? This element. Then it goes and sets I equal to 3, goes loops again, goes back to the top, sets I equal to 3. And it looks at, this is my new offset minimum value. And it's going to look at the 9.5. And this time, it's false, because this is not smaller than the old one. Okay, 9.5 is not smaller than 3.2. So then it skips this, and then it goes back up to the top again, and now it compares the 3.2 to the 7.2. Again, it gets to this line, says false, and it doesn't run this, and then it goes back up to the top again. At this point, I is now 5. Okay. So 0, 1, 2, 3, 4, 5. So now it's 5. It's no longer smaller than size because size is 5. So this is greater than size. So it jumps out of this loop all the way down out of this out to here. And then it returns the offset of the minimum, which was the location of 3.2. Okay. So then it goes back up here, executes this line, and prints out displays with that position. Okay. So this will be an important function for us to use. We'll find this very useful for us when we're starting to do searching and sorting arrays. This will be a useful one. There's another one called find max, which is a little bit different than this. The only thing you really need to do if you wanted to find the maximum, if you switch this arrow right here, that would actually find the max. And it's a good exercise to try that. Do like a find max function. Switch this arrow here, and you'll see how, and you can think about how it works and go through the process here. And then you can see how that would give you the maximum value. So that's a good one to go and try, is to create another function, do essentially all the same thing, and try to find the max of this array. Okay? And that's good for now.